Hello students, welcome to the class. So in the last class, we had discussed about chemistry in everyday life, where chemical substances, or you can say organic compounds, are being used in the field of medicine, pharmaceutical chemistry, in the field of food additives, in the field of foods, that is food additives they are called, and even we have seen as cleansing agents. Yes, then we have started with the polymers. In polymers, we have seen what are polymers, what is the mechanism of polymerization, and we have seen classification of polymers based on different various forms. Yeah, one is from origin, one is from the structure, one is from the molecular forces present in them, another one is the type of reaction taking place, addition or condensation, then another one is the type of monomers present. If there is a single type of monomer, we call it as homopolymer. If there are two different types of monomers, we call it as a copolymer. So here there are some of the examples regarding the polymers. Yes, one is natural rubber. Yes, what is natural rubber? Natural rubber is nothing but cis polyisoprene. Why it is called cis? Because if you look there, if you look at the structure of natural rubber, the CH2 linkages are there on the same side of the double bond. When they are on the same side, when any similar groups are on the same side of the double bond, we call them as cis. When they are on the opposite sides, we call them as trans. So natural rubber is cis polyisoprene. Yes, it is prepared from isoprene. It is prepared from isoprene. So what is isoprene? This is isoprene. What is the name? 1, 2, 3, 4 carbon atoms. 1 carbon, 2 carbon, 3 carbon, and 4 carbon. So I can call it as buta 1, 3 diene. But 1, 3 diene is called isoprene. It is called isoprene. So when but 1, 3 diene molecules, n number of molecules combine, it forms a cis buta 1, 3 diene. 1, 3 diene, and this is nothing but a polyisoprene. It is polyisoprene, or to a very, very perfect answer, you can give cis polyisoprene. So cis polyisoprene, that is nothing but our natural rubber. Yes, you can look at the structure of the natural rubber also. If the two CH2 groups, CH2 linkages are there on the opposite sides of the carbon-carbon double bond, then we call it as a trans polyisoprene. You can see here the two CH2 groups are on the opposite sides. You can see here there is one CH2 linkage, and here there is another CH2 linkage. So since they are on the opposite sides, it is called trans polyisoprene. And this trans polyisoprene, it is having another name, that is gutta percha. It is called gutta percha. Yes, coming to the next one, there is one more compound, that is neoprene. Neoprene is nothing but it is a rubber. It is obtained by polymerization of chloroprene. 1, 3 2 chloro 1, 3 butadiene. 2 chloro 1, 3 butadiene is called chloroprene. When you subject it for polymerization in presence of organic peroxide or O2, you get neoprene. That is the synthetic rubber. The another name for neoprene is what? Synthetic rubber. So neoprene is an extremely strong rubber which is used in the preparation of grip soles of shoes, suits for divers, domestic articles, paints, adhesives, cement, etc. Yes. Coming to the next one, SBR, styrene butadiene rubber. It is also called Buna S, styrene butadiene rubber. It is prepared from two different monomers. Therefore, it is an example for copolymers. It is an example for copolymer because two different monomers are being used. What are the two different monomers? 1, 3 butadiene is one monomer. You can look here, and another monomer is styrene. When these two combine, when they undergo addition reaction in presence of sodium, you get this compound which is called Buna S. It is nothing but SBR, styrene butadiene rubber. Why it is called Buna S? Yes, butadiene, Bu is taken. This reaction is carried out in presence of sodium, therefore Na, and with styrene, therefore S. So it is called Buna S. It is called Buna S. You have one more which is called Buna N, which is called Buna N. Yes. So these are all the examples for copolymers. See, bunaias is largely used in preparation of tires, as also in the preparation of rubber shoes, soles, heels of shoes, belts, pipes, etc. Polyvinyl chloride, PVC. Polyvinyl chloride is commonly known as PVC and is the most commonly used thermoplastic polymer. It is prepared by addition polymerization of vinyl chloride. You can see here, this is vinyl chloride. When you carry out polymerization, that to which polymerization, addition polymerization, we get polyvinyl chloride, that is PVC. It is used in preparation of pipes and all, tubes, raincoats, curtain stacks, vinyl flooring, luggage and all. Yes. It is also used in electrical insulating wires, that is PVC wires are being used. It has found many uses. Then we have polytetrafluoroethylene. That is nothing but commonly called as Teflon. You can look here, tetrafluoroethylene. Carbon, then here there is fluorine, fluoroatom, double bonded C, fluoro. When this is subjected for addition polymerization in presence of oxygen, what we get is we get C, F, double bond becomes single bond C, F. This continues up to N molecules when you have taken here N molecules. This is nothing but tetrafluoroethene, which is commercially called as Teflon. All your non-stick utensils, what you use, they are having this coating, Teflon coating. Yes, they have Teflon coating. So where Teflon is used, it is used in the preparation of many heat resistant and chemical resistant articles. For example, your non-stick layer of kitchenware, gaskets, tapes, piston rings, all of them contain Teflon coating. Next is nylon 66. Nylon 66 is an example for condensation polymers. It is an example for condensation polymer. So condensation means what? There is elimination of small molecules. So now the question is why it is called nylon 66. You can see here it is prepared from adipic acid, which is nothing but hexane dioic acid, and another one is hexamethylene diamine. They undergo condensation with the elimination of water molecules. So they undergo condensation and give us this. Why it is called nylon 6,6? The reason is the two monomers used, they contain 6 carbon atoms. You can see here one carbon, CH2 4 times. That means 4 carbons, 4 plus 1, 5, 5 plus 1, 6. And here also CH2 6. So both the monomers contain 6 carbons each. Therefore, this has the name nylon 6,6. It has the name nylon 6,6. Okay. So next, nylon 6, which is also called Perlon. It is synthesized by polymerizing caprolactam. Caprolactam has got 6 carbon atoms. Therefore, it is having the term nylon 6. Nylon 6 is used in the preparation of fibers, cloth wearing, weaving, threads present in tires, ropes, etc. Next is phenol formaldehyde resin. This is having the common name, that is bakelite, phenol formaldehyde resin. Phenol adds on formaldehyde in presence of an alkali to form a mixture of ortho and para hydroxy benzyl alcohols as intermediates. That is called novolac. These further react to undergo polymerization to form phenol formaldehyde resin. The cross-linked polymer so obtained is known as bakelite. You can see here, this is the structure for when you take phenol and formaldehyde, you get the ortho and para hydroxy benzyl alcohols. They will react with phenol and give us bakelite. So what is the structure for bakelite? The structure for bakelite, this is the structure for bakelite. It is cross-linked structure. So in bakelite, the polymeric chains are joined together by CH2 bridges. Therefore, bakelite is a thermosetting polymer. That means when you heat a bakelite, it will become hard. Yes, it will become hard on heating. So only the name thermosetting polymer, which is widely used in the preparation of electrical appliances, gramophone, records, formica, fountain pens, parts of machinery, combs, and so on. Yes. So before going to the multiple choice questions, here I have to discuss a few more synopses based on Environmental chemistry. Yes, the topic, a very simple topic. So I have not included much on it. So I will discuss it here. Environmental chemistry. The first PUC topic of yours, environmental chemistry. So what all you have studied here? You have studied, it is nothing but it is a scientific study of chemical and biochemical phenomena that occur in the natural places, right? So you know that Earth's environment, it comprises of four major components. Which are they? One is atmosphere, then you have hydrosphere, then you have lithosphere, and then you have biosphere. Yes, so these are the four major components of Earth's atmosphere, Earth's environment. Yes, so atmosphere means what? It is a layer of gases surrounding the Earth. Yes, and these gases are retained by Earth's gravity. And you know what is the structure of atmosphere, so composition of atmosphere. 78% nitrogen is there, 21% oxygen is there, and then 0.9% argon is there, and then 0.038% carbon dioxide is there, and very trace amounts there are other gases. This is atmosphere, what you know. Yes, then you have studied, you know about hydrosphere. Water, hydro means water. Yes, so it collective mass of water found under and over the surface of our planet is coming under hydrosphere. Lithosphere is nothing but the solid component of the earth, containing your soil, rocks, mountains, and all. Yes, outermost thick solid part of the earth is called what? It is called crust. It is called crust. Yes, uppermost part of the earth's crust contains weathered rocks as well as organic matters. Biosphere is what? It is a part of lithosphere, hydrosphere. See, lithosphere is there, hydrosphere is there, and then atmosphere is there. When all these three combine, you have this, you know, union of all this. This is biosphere, where life exists, where life exists. So this is biosphere. Okay, so this is biosphere. So you know all about this. Fine. Then coming to atmosphere. See, we are going to discuss pollution which occurs in atmosphere under two different cases. When you look at the atmosphere of our Earth, if you see, if I say this is, if I take up something like this, okay. So if I consider this as altitude, and this, yes, let me say this as altitude. So let me go on marking here altitude in in kilometers. If I go on marking, so say I have these kilometers here. Let me say this is 10 kilometer, 20, 30, 40, 50, 60, 70, 80, 90, say 100. Yes, I have kilometers like this. So if you see here, up to 10 kilometers, up to 10 kilometers, what is there? Up to 10 kilometer, up to 10 kilometer. This is called what? This is called troposphere. Troposphere. Yes, it is called troposphere. Then from 10 kilometers to 50 kilometers, from 10 kilometers to 50 kilometers, what it is called? This is called stratosphere. Then from 50 kilometers to around 88 kilometers. Yes, you might have studied this. What it is called? It is called mesosphere. Then from 80 kilometers onwards, 90 kilometers to 120 kilometer. 110, 120, say 120 kilometer. This is called ionosphere, thermosphere. It is called thermosphere. Now here, if you see, a troposphere is 0 to 10 kilometers, stratosphere is 10 to 50, mesosphere is 50 to 85 around, thermosphere is 85 to 500. It goes, it continues. Okay. So if up to 500 kilometers we have. The region between this sea level, this is sea level, and this troposphere, the region between troposphere and stratosphere, this region, what you are saying, it is called tropopause. What it is called? It is called tropopause. The region between troposphere and stratosphere. The region between stratosphere and mesosphere is called stratopause. You should be knowing this. It is called stratopause. The region between mesosphere, above mesosphere and thermosphere, it is called mesopause. Yes. Then last you have exosphere. Exosphere comes after thermosphere. Exosphere is above 600 kilometers. It is above 600 kilometers. It is exosphere. Yes. So these are the layers of atmosphere. These are the layers of atmosphere. Now, why I am saying all these things is, see, here we are going to discuss the pollution which occurs in troposphere and the pollution which occurs in stratosphere. Now, let me say what pollution occurs. See, around here, around 30 kilometers above, there is one layer which prevents the earth from harmful radiations. That layer is called what? Ozone layer. So we are going to discuss in stratosphere the depletion of ozone layer, and in troposphere the various pollutions which are being caused in the atmosphere. Okay. So now any undesirable change which occurs in our environment and that is harmful to plants, animals, human beings, we call it as environmental pollution. And that substance which causes pollution is called a pollutant. So pollutant is not always a substance which is poisonous. Those useful substances, if they are present in more than required amounts, they also cause pollution. Like for example, I'll give you a simple example. You have heard about carbon dioxide. You call it as a greenhouse gas, right? You call it as a greenhouse gas. But if the level of carbon dioxide due to deforestation, due to overuse of automobiles, what is happening? The level of carbon dioxide in the atmosphere is increasing, which is causing the temperature of the earth to get heated up. That you call it as a global warming. So here, though carbon dioxide is required in nature, but if its level goes above, what happens? It becomes a pollutant. Here in pollutants, you have types of pollutants. One is primary pollutant and another one is secondary pollutant. So primary pollutants means what? They are those pollutants which remain as such after the formation. Like for example, oxides of nitrogen, sulfur, carbon are being evolved from automobiles and industries, right? For example, nitric oxide is there. Yes, you have an example, nitric oxide, NO. Then you have sulfur dioxide, SO2. Then nitrous oxide, nitrogen dioxide, NO2. Then carbon monoxide, CO, hydrocarbons. So these are all what? These are all primary pollutants. They are primary pollutants. So they remain as they are, primary pollutants. Yes. Then we have something called secondary pollutants. What are secondary pollutants? Secondary pollutants are nothing but they are formed from primary pollutants in the atmosphere. Yes. For example, hydrocarbons and oxides of nitrogen. These hydrocarbons and oxides of nitrogen, they react to form a certain compounds which are called peroxyacetyl nitrates. These are abbreviated as PAN. So these become the secondary pollutants. They act as secondary pollutants. Second set of pollutants are degradable and non-degradable pollutants. Degradable pollutants degrade after some time, either automatically because of heat or through the action of microorganisms. That is your sewage. Yes. Non-degradable pollutants are what? They do not degrade into the atmosphere. They do not decompose into the atmosphere. Example, your DDT, plastics and all. So medium, that is our soil or the organism affected by pollutant or contaminate is called receptor, while sink is a chemical medium or species that retain and interact with the pollutants. Yes. Okay. Atmospheric pollution. In tropospheric, what happens? Oxides of nitrogen are there, oxides of sulfur are there. They are causing pollution. Yes. Nitric oxide. What happens? Nitrogen and oxygen combine to form nitric oxide. Nitric oxide combines with oxygen. You might should be knowing all the reactions. Nitrogen and oxygen combine at certain temperatures. It forms nitric oxide. Nitric oxide combines with oxygen at around say 1100 degrees Celsius and forms nitrogen dioxide or nitric. Yes, nitrogen dioxide combines with ozone sometimes to form nitrogen dioxide and O2. Yes, so this nitrogen dioxide, when comes into the atmosphere, becomes oxide of nitrogen, which is which causes tropospheric pollutants. Even sulfur dioxide. Sulfur dioxide combines with oxygen and forms sulfur trioxide. This is also a pollutant into the atmosphere. Now you may say how it is a pollutant. When it combines with rainwater, for example, when it combines with rainwater, it forms H2SO4. It makes rainwater more acidic. Yes. Therefore, we say sulfur dioxide is a corrosive acid gas, which produces acid rain and causes damage and destruction to the vegetation, degradation of the soils and building materials also. Yes. So it is called what? It is called as a corrosive acid gas, which is called corrosive acid gas, sulfur dioxide, corrosive acid gas. Yes. Okay. Then it also limestone materials act as a sink for sulfur dioxide. Limestone materials act as sink for sulfur dioxide. Okay. Then hydrocarbons are also pollutants. They are majorly produced naturally, like you have marshy gases, CH4, or due to incomplete combustion of the automobile fuels. Yes, they combine polynuclear aromatic hydrocarbons. You might have heard about PAN, PAH, polynuclear aromatic hydrocarbons. These are carcinogenic. They cause cancer. They are carcinogenic. They cause cancer. Yes. Then oxides of carbon. You have carbon monoxide. You have carbon dioxide. Yes, carbon monoxide is a toxic gas which is emitted into atmosphere by incomplete combustion of coal and firewood and by oxidation of hydrocarbons. Yes, okay. Carbon monoxide may reduce the oxygen carrying capacity of the blood by combining with hemoglobin to produce carboxyhemoglobin. This oxygen deficiency results into headache, weak eyesight, nervousness, and cardiovascular disorders. Carbon dioxide, it is released into the atmosphere by respiration, burning of the fossil fuels, forest fires, decompositions. Yes, what is carbon dioxide? It is a greenhouse gas. Yes, if its concentration increases, it causes rising of the temperature of the globe, which is called global warming. We'll see again what is global warming also, right? Then it's in excess, it causes headache and nausea. Greenhouse effect and global warming. Now see, greenhouse effect. Now what is greenhouse effect? Greenhouse effect means what? It is a process. See, greenhouse effect. It is a process in which emission of infrared radiations by the atmosphere warms the Earth's surface. Yes. So here we have greenhouse gases. Which are the greenhouse gases? CH4 is the greenhouse gas. We have carbon dioxide, which is a greenhouse gas. But when these carbon dioxide, especially carbon dioxide, due to deforestation and all, when the radiations, outgoing radiations emitted by the carbon dioxide by the surface is at the wavelength, that is absorption range of the many atmospheric gases. Yes, these radiations are thus locked in the Earth's atmosphere. So when carbon dioxide concentration increases, the radiations, infrared radiations also increase, due to which the radiations which get trapped in the Earth's atmosphere, there will be steady increase in the temperature of the Earth. It results in what? It results in global warming. It results in global warming. Yes, so global warming can result in major climatic changes, including melting of the polar ice caps. It is estimated that such melting of polar ice caps may raise the mean sea level by 0.5 to 0.5 to 1.5 meters. 0.5 to 1.5 meters in the next 100 years. Within 100 years, this is expected. Now you may say what difference it is going to make. If it raises from 0.5 to 1.5 meters, then all the coastal cities, will submerge underwater. All the coastal cities will submerge under water. So this is greenhouse effect and greenhouse gases. Then what is acid rain? See, normal rainwater, the pH of normal rainwater is 5.6. I may say it is acidic, right? Slightly acidic. Yes, that is required because when this rainwater falls to the soil, the minerals present, they are present in the complex form here. When this acidic rainwater, slightly acidic rainwater falls, it will break down these complex substances. Yes, complex minerals are being broken down. But what now you may say how this rainwater becomes slightly acidic. When rainwater is coming to the earth, it gets combined with carbon dioxide and it forms carbonic acid. So normal rainwater is present as carbonic acid, therefore pH will be slightly acidic, 5.6. But if the carbon dioxide level increases in the atmosphere, what will happen? Water combining with the CO2, it becomes more and more acidic. So pH falls below 5.6. It falls below 5.6 and such rain is said to be acid rain. If the pH of the rain is less than 5.6, it is called what? It is called acid rain. It is called acid rain. It causes damage to the buildings which are specially made of limestone. That damage we call it as stone leprosy. We call it as stone leprosy. Yes, you might have seen the Taj Mahal, monument of India. Taj Mahal had developed yellow patches. It's a white marble, but it had developed yellow patches. Why Taj Mahal only? Because if you look the surrounding of Taj Mahal, there are hundreds of factories and industries, and they were giving out sulfur dioxide, nitric oxide. They were emitting these gases. So these gases combined with water, they combined with water and formed the respective acids H2SO4, HNO3, and that was due to which the pH of rainwater was reduced below 5.6, and that caused acid rain. Yes, okay. What are the harmful effects? It causes extensive damage to the buildings and statues of marbles, limestone, etc. Yes, why? Because marble and limestone is nothing but calcium carbonate. When H2SO4, that is your acid rain, combines with it, it forms calcium sulfate. This gives a yellowish patch, plus carbon dioxide again is released, plus H2O. Yes, because of this reaction. It is even toxic to vegetation and aquatic life. Yes, so that are the harmful effects of acid rain. Next, particulate matter we say. We are viable and non-viable. Viable means they are living, bacteria, fungi, molds, algae. Non-viable means your smoke, dust, mist, fumes and all. Yes, they are non-viable. Okay, then what are the health effects on particulates? Whatever I said is particular matters, they cause you might have seen smoke. It consists of solid mixture of solid and liquid particles. Yes, oil smoke can be cigarette smoke or smoke from fossil fuels. Dust, yes, it consists of fine particles produced during crushing or grinding of the solid materials. Like you, for example, cement comes out as a dust. Fly ash, silica dust, dust storm. Yes, then mist we have. These are formed by particles of spray liquids and condensation of vapors in air. Yes, so fumes, they are produced during condensation of the vapors. These are all particulate matters. They are being classified as viable and non-viable. So viable is what? Which are living, small sized living organisms, bacteria, fungi, molds, algae and all. Non-viable means what? These smoke, dust, mist, fumes come under. What are the harmful effects on particulates? Smaller particles, they penetrate into the lungs. Yes, pneumoconiosis, that is pneumonia. Yes, they irritate lungs. Sometimes they cause lung cancer, bronchial asthma. Yes, particulate such as asbestos causes asbestosis. Dust containing free silica causes silicosis. Yes, coal miners, they suffer from black lung disease, while textile workers suffer from white lung diseases. So these are all the diseases which are caused due to particulates. Yes, okay. Then particulates provide nuclei for cloud formation. and increase fog and rain. Yes, so this is all about the harmful effects of particulates. Then smog. We have heard something regarding smog. What is smog? It is a combination of smoke and fog. Smog is a chemical mixture of gases that form a brownish yellow haze primarily over urban areas. Why over urban areas? Because there is lot of industrialization and what you say, automobiles moving here. Yes, so because of this we have smog in the urban areas. It is not fog, students. Smog irritates the eyes, whereas fog is natural phenomena. Now this smog is was studied under two different types. One is classical smog, which is also called London smog. Yes, one is classical smog. Classical smog. The other name for classical smog is London smog, or you can also call it as sulfurous acid smog. This smog, it occurs in humid climate. It occurs in humid climate. Yes, it occurs in humid climate. This was found in London, therefore it is also called London smog. It results from the accumulation of smoke from coal burning, which has high sulfur content. Yes, okay. So this is chemically reducing in nature. It is chemically reducing in nature. You should be knowing the characteristics of this, because why it is reducing in nature is because it has high concentration. It has high concentration of SO2. So this is one type of smog. The second type of smog is photochemical smog. Photochemical smog. It is also called Los Angeles smog because it was found in Los Angeles. Yes, this is formed in warm, dry, and sunny climate. Photochemical. Photo means in presence of light. Therefore, it is found in sunny climate. Yes, photochemical smog is the result of chemical reaction of sunlight with nitrogen oxides and volatile compound, that is hydrocarbons. Yes, this is photochemical smog. Ozone reacts with hydrocarbons to form aldehydes and ketones. Nitrogen oxides, oxygen, and ketones combine to form PAN, that is peroxyacetyl nitrates, PFN, that is peroxyformyl nitrate, PBN, that is peroxybenzoyl nitrate. So PAN, peroxyacetyl nitrate, then you have PFN, peroxyformyl nitrate, then you have PBN, peroxybenzyl nitrate, peroxybenzyl nitrate. Photochemical smog is characterized by brown, hazy fumes. Why you get brown hazy fumes? It is because of NO2, nitrogen dioxide. Because of nitrogen dioxide, you get brown hazy fume. It irritates the eyes and the lungs. Even PAN attacks the leaves of plants, causing bronzing and glazing of their surfaces. It corrodes the materials, you can say metals also. Yes. Then we have stratospheric pollution. This is all tropospheric pollution. Next is stratospheric pollution. Under stratospheric pollution, what all comes? One is your chlorofluorocarbons, which are responsible for ozone layer depletion. So chlorofluorocarbons, they are commonly called freons. Freons are chlorofluorocarbons, yes. So these are released into the atmosphere from aerosol sprays, refrigerating equipments. They undergo photochemical decomposition and destroy ozone. How do they destroy ozone? I can just explain you. Dichloro-difluoromethane is a chlorofluorocarbon. In presence of sunlight, it will undergo free radical reaction and it will give us chlorine free radical. This chlorine free radical, or you can take any of the freon. You can take a CFCl3. This is another trichlorofluoromethane. This will, in presence of sunlight, it will form CFCl2 free radical plus one more chlorine free radical. So these CFCs, they release chlorine free radicals. This will go into the stratosphere where there is ozone. It will react with ozone molecule and it will form ClO free radical plus O2. This ClO free radical combine with another oxygen atom and it will form Cl free radical plus O2. So these Cl free radicals go on producing and they go on reacting with each and every ozone molecule. So these chlorine free radicals generated in course of reaction, it has been found one molecule of CFC or one chlorine free radical can destroy more than thousands of ozone molecules in the stratosphere, and that we call it as ozone depletion. Ozone depletion, this was for the first time, there is hole being created, it was for the first time observed in Antarctica. Yes, in most parts of stratosphere, ClO free radical reacts with nitrogen dioxides and also hydrocarbons. Yes, so this prevents the active chlorine species from reacting with more ozone, slowing down the ozone depletion. Okay, now what are the effects of ozone layer depletion? What happens? All the harmful ultraviolet radiations can enter the atmosphere, due to which it causes skin cancer, eye damage like cataracts, a small grayish layer develops on the eye, immune system damage occurs, damage of plants, crops, disturbance of heat balance of the earth, all takes place. Water pollution, you have seen, because this is a very common topic. What happens in water pollution? In water pollution, due to industrial effluents, mining, agricultural wastes, sewage disposals and all, they cause the water unfit for drinking and for domestic use, that we call it as water pollution. In the types of water pollutions, you have two. One is microbiological pollution, another one is chemical. Microbiological pollution is because of the bacteria and all. Because of the presence of bacteria and all, there occurs pollution, and we call it as microbiological pollution. Yes, this is microbiological pollution. Second one is chemical pollution. What happens when the industrial effluents are being let out into the water bodies? There are harmful chemicals, heavy metals are present, like for example cadmium is there, mercury is there, nickel, lead, solvents are there like polychlorinated biphenyls. These chemicals, they break down the natural wastes present in the water, and they will destroy the aquatic life. So harmful effects of water pollution, you already know. See, persistent pesticides such as organochlorine, chlorinated hydrocarbons, DDT, you can take. What happens? They pass into the food chains and increase in the amount per unit weight of the organisms, with rise in the trophic level due to their accumulation in the fats. That phenomenon is called what? Biomagnification. It is called biomagnification. Here you might have studied about one more important term, that is, you might have heard about this term. It is nothing but eutrophication. Eutrophication. Now, what is this eutrophication? Eutrophication is a process where water bodies recessive excess nutrients that stimulate excessive plant growth. Yes, algae, periphyton, fungi, and all they grow. This enhanced plant growth, often called algal bloom, reduces dissolved. See, in the water bodies, the aquatic life survive. It might be plant or it might be animals. They survive because of the oxygen which is dissolved in the water bodies, and that is called dissolved oxygen. But what happens during eutrophication is excessive plant growth upon the surface of the, there is plant growth here. So these plants, what they do, they will take the oxygen which is dissolved in the water bodies. So when they take the oxygen, the decrease in the level of oxygen, see, excessive plant growth you can say, or you can say sewage also. When sewage increases in water bodies, they will all take the oxygen from the water bodies. So dissolved oxygen level goes on decreasing, due to which the plant aquatic life present inside into the bulk of water bodies, they die. So this reduces the dissolved oxygen in the water. When dead plants materials decompose, it causes other organisms also to die. So there will be natural death of the organisms. Yes. So this is called eutrophication. Water with a low concentration of dissolved, when concentration of dissolved oxygen reduces in water, such water is called hypoxic water. It is called hypoxic water. So what is hypoxic water? Dissolved oxygen has decreased. The level of dissolved oxygen has decreased. Yes. So here, to understand this, we have BOD, biochemical oxygen demand. the total amount of oxygen in milligrams consumed by the microorganisms in decomposing the waste in 1 liter of water, yes, is called during a period, even if a period is given, during a period of 5 days, is called biochemical oxygen demand. It is used to measure the degree of water pollution, how much water pollution is there. If there is a low BOD, it means it is a good quality water, good quality water. If there is a high BOD, it means it indicates, if there is high BOD, then it indicates that that water is polluted water. It is polluted water. Yes. Chemical oxygen demand. You have one more, COD. So what is COD? It refers to amount of oxygen expressed in parts per million consumed under specific conditions. So COD is used as a measure of oxygen requirement of a sample that is susceptible to oxidation by strong oxidizing agents. Okay. Then soil pollution. This is all about water pollution. What happens in soil pollution? Excessive use of fertilizers, insecticides, pesticides, herbicides, fungicides. All these are pesticides, right? What are pesticides? They are nothing but chemicals that are used to kill or stop the growth of unwanted organisms. But they have very bad effects, adverse effects on human beings' health as well as the soil. Like we use insecticides, DDT, BHC is used, adrin is used. Yes. Then we use herbicides. Herbicide is NaClO3, sodium chlorate, and sodium arsenite, most commonly used herbicides. Yes. So under pesticides, we use insecticides. Commonly used insecticides are DDT, dichlorodiphenyl trichloroethane, BHC, benzene hexachloride, aldrin. Yes. So these are used. They stay in the soil for a long time. Yes. Then we use herbicides. Like herbicides used are NaClO3, sodium chlorate. Then you use Na3ASO3, sodium arsenite. They are no longer preferred, but these were the herbicides being used. Yes. Nowadays, what herbicides are being used are triazines. These are being used. They also remain into the soil. Then we use fungicides. Yes, organomercuric compounds are mostly used as fungicides. Organomercury compounds, they are used as fungicides. So they remain into the soil. Second type, so these are all pesticides. This is first way of polluting soil. Second is industrial wastes. So large number of toxic substances are released into the industries, manufacturing industries and all, where therefore the many of the harmful or heavy metals come in contact with the soil. Then these do not decompose so easily. Like for example, you have cyanides, chromates, mercury, copper, zinc, lead, cadmium and all come into the atmosphere. Radioactive pollutants also come here. Radioactive pollutants. Yes, dumping of nuclear waste from nuclear power plants into the soil has become one of the greatest sources of radioactive pollutants. How to control environmental pollution? First way, how to control this environmental pollution? The first way is waste management. Waste management has to be done. Yes, so waste management. Environmental pollution can be controlled to a certain extent by managing the waste disposal in a proper way. The second way is recycling. When you recycle the materials, you can reuse them and reduce it. Yes, so these 3 R's are very important. 3 R's we call: reduce the use, then recycle, and then reuse. The third way is incineration. Yes, so incineration is what? Waste treatment technology. It involves combustion of organic materials and substances. So incineration of waste materials, what happens? It converts the waste into ashes, flue gases, particulates and heat, which can in turn be used to generate electricity. So incineration is the best method. Incineration reduces the volume of original waste by almost 95%. It reduces the volume by almost 95%. Then last part in this, what you have seen is about green chemistry. Green chemistry. Yes. So green chemistry, it is a chemical philosophy encouraging the design of products and processes that reduce sometimes or eliminates the use and generation of hazardous wastes. Reduces or sometimes eliminates hazardous wastes. Yes, steps are different and all. So green chemistry, it refers to redesign of chemical products and processes with the goal of reducing or eliminating any negative environmental effects. Examples of green chemistry projects: finding non-toxic, non-volatile solvent substitutes. Sometimes some we will be using some solvents which will be toxic. You can replace it by non-toxic or non-volatile solvent, and so on. Developing new catalysts and environmental friendly materials. So this is all about the environmental chemistry which you had discussed in your first PUC. So based on these three topics, that is chemistry in everyday life, and then polymers, polymer chemistry, and then environmental chemistry, in the next video we'll be discussing about the questions. We'll be discussing about the multiple choice questions. We have ample number of multiple choice questions. We'll be discussing all of them. For now, I hope the synopsis on all the three topics are clear. Thank you.